Lots of mail came in. Better get to it. According to this, we received a diode. Just one in all of this little... What? Okay, that does not look like a diode. It looks like something in an 8-pin SOIC, perhaps. 555 chips, surface mount. I've been waiting for these for so long. And now I can put breakout boards similar to these to good use. I can take these surface mount chips, put them on boards like this, and have 0.1-inch header breakout boards. And now that I have lots of flux, stuff like this will go a lot easier. 50 pieces, any 555 timers, SOP package, $1.21 from Orchid. And because it's a chip with a chip part number, there's really nothing else they say about it. But they do come in this nice packaging. So it's just a little strip of surface mount chips that you can keep somewhere and take them out as you need them, solder them to those little surface mount to through-hole breakout boards and use them as you need. And if you actually do a board layout or something and you want to use surface mount to make it small, you've got a bunch of these on hand, and these are universal. They're going to be useful forever. So a strip of 50 of these for just over $1, well worth it, even if you only need a couple right now. So that was diode, and that was a lie. This is electrical parts, and it's most likely true. So, okay, it's kind of true. It's plastic potentiometer knobs to be used for electronic parts. I think this can be used for a half-moon shaped potentiometer knob. I will put these knobs in the tray where I've been collecting these up and revisit this later. Lot of 10, D-shaped half-moon shaft, audio, auxiliary, amp, pedal, effect, potentiometer knob, W03B. I'm not sure what the W03B is, maybe some little part number, or maybe it's a common part number. 10 of these are 99 cents from Hong Kong Superseller. So this whole D-shaped half-a-moon shaft thing, you can fit one of those D-shaped potentiometer shafts. So it's not the regular circle one with all those spines on it, like this one, which I think they call a knurled, with a K, knurled shaft. It's these half-a-moon ones, kind of like a split shaft. So I have several things like this, including a rotary encoder, and I needed these special pot knobs. Now, this isn't a very good picture of it. They're showing a side profile and then what it looks like inside. But I think I ordered different sizes and styles of the knobs, so this is one of several. So about 10 cents each. I think I'll be set for a while. To go with all this electronic stuff, we have integrated circuits of an unknown, undisclosed nature. Well, that's a lot of stuff. Actually, those are modules. Those aren't just integrated circuits. Ooh, it looks like I cut right into one of them. Okay, I figure these all look the same. Wow, I cut right through the Ziploc bag as well. Here's the regular access point. Direction, step, sleep, reset. Okay, this is starting to sound like a stepper driver with A and B phases and power supplies and enable some sort of adjustment potentiometer. HR4988. 5 pieces, A4988, StepStick, stepper, Driver+Heatsink for Reprap, Pololu, 3D printer red. Okay, I think they're trying to market this for a 3D printer and the board is red. Anyway, it's an Allegro Micro 4988 Microstepping driver. 5 of these are $4.89 from Hero Neo 2012. I guess somebody's a Matrix fan. So there's a little trimmer pot. I think that sets the current limit for the motor so you don't draw too much current. And they do give you a heat sink so you can presumably, hopefully, draw the maximum current the chip can give. And here's some copying and pasting, most likely. Very important to point out, the color is red, and you point that out in pinky purple. So it's a CMOS microstepping driver with transistor and overcurrent protection. You can operate bipolar motors in... Oh, you know what? Why don't I just go to the data sheet, because it's going to have all of this, literally, and more. Allegro Microsystems 4988 Microstepping driver overcurrent protection. Okay, so this runs at 3.3 and 5 volts for the logic side, and then you can run a motor up to 35 volts and you can run 2 amps, but then you'll need a heatsink. You can select 5 step modes. You can go normal, full step, half, quarter, eighth, and 16th microsteps. So built-in translator for easy operation. I think that pretty much means you give this a clock and an enable, and it'll do what it needs to do to control the phase outputs. You give it 1 step pulse on the step input to drive it 1 microstep. No phase sequencing tables and complex interfaces. So if you just want to use this in a simple application and you don't want to have a lot of processor overhead, you can use an interface like this. Sounds like a good fit for an Arduino. Tell it to go, tell it how far to go, and it'll figure out how to get there. Here's the interface. VDD would be the logic supply, 3.3 or 5. This could be our Arduino. Some little control and enable and reset sort of stuff here. These microstep control inputs decide if you're doing full stepping down to 16th steps. And here's your step clock. Every time you do a pulse, you will step the motor whatever amount you've selected. And you can control the direction with this. And VBB would be the actual motor supply. The motor supply can be 8 to 35 volts, and the logic supply can be 3 to 5.5, so perfect for Arduino. Overcurrent protection, when you get to 2.1 amps, thermal shutdown, so this should do a reasonable job of protecting itself, no matter what we do to it within reason. Again, perfect for Arduinos on the workbench. So I'll need to dig out a stepper motor and play around with this. I have steppers scattered all throughout the basement, but I have not seen them in years. And I do have an old inkjet printer that I think I might be able to harvest some stuff out of. So, fun times coming. We have some more electronics right here. And it's wrapped in bubble wrap. Oh, chips. Now they have pink anti-static looking storage foam, but it doesn't look like this is anti-static bubble wrap for shipping. Oh well, good thing we're not doing something for production, right? If it doesn't work on the bench, no big deal. That's why we order a million things. Something's got to work. If I could get into it. Whatever it is, there's 10 of it. Oh, CD4040. I believe that's some sort of binary counter thing. I was using stuff like that for my digital audio sound synthesis project, dividing an oscillator down and getting octaves that give musical intervals. Maybe it's time to get back into more of that. 10 pieces. CD4040 ripple carry binary counter divider IC, $1.78 from Satisfy Electronics. So there's a few chips in this series, a 4020, a 4024, and a 4040, that are all ripple carry binary counters dividers. They just have different number of stages. So this can basically do clock dividing. If I really wanted to divide a lot, I can get up to Q14 on this 4020. But in order to give us these many stages with only a 16-pin package, they sacrifice the first couple of Q2 and 3 outputs. What we're really concerned about is dividing it a lot more. So we don't really care necessarily about what's going on in the beginning. We just want a big, heavy division. We'll get this chip. But I want to be able to tap in and get each one divided. So I'm going to use the 4040, so I get Q1 through Q12 with nothing missed. I just only get to go to 12 instead of 14. So however you want to look at it, it's either a binary counter or a clock divider. Either way, standard CMOS 4000 series logic. Good to have collections of parts around if you want to be experimenting with discrete logic here and there. And here are some 3mm diodes, which I assume are LEDs in a nice plastic enclosure. Yes, and it has Scotch tape holding it together. I will assume these are white when they're on, and then we have red, yellow, green, blue LEDs. Yeah, very small LEDs. And when you have like 20,000 of them, they will find their way into any number of projects to come. And they will find their way into each other's compartments. 3 or 5 millimeter red, green, blue, yellow, white LED light emitting diodes assortment kit. I bought 500 pieces of the 3 millimeter ones this time for $3.99 from RR0493. You can get just 100 pieces, 150, 200, 300, etc. And you can choose, they have different options of 5 millimeter or 3 millimeter. So I got these tiny ones and as many as I could just to have around colorful LEDs. If I want to test out one of those binary counters or something like that, I can throw some LEDs on the breadboard and see that the circuit's working without having to go and rig up a logic analyzer. They give a little table here covering the 500 pieces of 3 or 5 millimeter. Now I don't know if the specs are identical for the 3 or the 5 millimeter versions. That's what this implies. So they give you the wavelength of those 5 colors, the forward voltage and current, and you get 100 of each of the colors. So, you know, I'm going to take these specs with a grain of salt. They look standard anyway, but we're not doing a production design where we have to be sure. We just need things to work without burning out on the breadboard. So ballpark it, use some common sense, and throw in a proper current limiting resistor, and we're good. Okay, so we have some driver chips with heat sinks for the ICs, potentiometer knobs, CMOS logic, 555 chips, lots of them, and tiny LEDs to light up your day. More stuff to have on hand when you need it, and it's good to know it's there.